At the edge of a large metropolitan interchange, multiple streams of vehicles merge, diverge, and realign without stopping. Trucks maintain steady trajectories across long distances, passenger cars adjust speed within narrow margins, and lane changes occur within clearly bounded spaces. The scene appears fluid, but beneath that movement is a fixed spatial assumption. Every driver is operating within lanes that are nearly identical in width. This consistency is not incidental. It is the outcome of a long institutional process in which transportation agencies, engineering, bodies, and regulatory systems converged on a shared standard for how wide a highway lane should be, and more importantly, how that width should remain stable across regions, jurisdictions, and time. In the United States, for example, most highway lanes are built to a standard width of 12 feet. In many other countries, the equivalent standard falls within a narrow range around 3.5 meters. These numbers are not chosen arbitrarily, nor are they merely recommendations. They are embedded in design manuals, enforced through project approvals, and reproduced through construction practices that depend on uniformity. The origin of these standards can be traced to the early expansion of road networks in the 20th century, when increasing vehicle speeds began to expose inconsistencies in road design. Before standardization, lane widths could vary significantly, even within short distances. Rural roads, urban streets, and early highways were often built according to local constraints or available space, resulting in unpredictable driving conditions. As vehicle speeds increased and traffic volumes grew, these variations became a source of risk. Drivers could not rely on a consistent sense of lateral space. A lane that narrowed unexpectedly required rapid adjustment, and in high-speed conditions, even small deviations could lead to collisions. What had once been manageable at lower speeds became unstable at higher ones. In response, transportation authorities began to formalize road design. Engineering organizations conducted studies to determine how much lateral space a vehicle required, taking into account not only the physical width of vehicles, but also the behavioral tendencies of drivers. Vehicles do not travel perfectly centered. They drift slightly within a lane. Drivers require a margin of error to maintain control, without constant correction. This led to the development of design guidelines that specified minimum lane widths, capable of accommodating both vehicle dimensions and human behavior. These guidelines were not static. They evolved through iterative testing, observation, and revision. As vehicles became larger, faster, and more numerous, the standards were adjusted accordingly. Once established, these standards were incorporated into national and regional design manuals. In the United States, documents such as the Green Book, published by the American Association of State Highway and Transportation Officials, AASTO, codified recommended lane widths for different types of roads. Similar documents exist in other countries, each serving as a reference for engineers, planners, and contractors. The role of these manuals extends beyond recommendation. They function as a baseline for project approval. When a new highway is proposed, its design must align with these established standards. Deviations are not impossible, but they require justification and are subject to additional scrutiny. This creates a system in which consistency is not only encouraged but institutionally reinforced. Construction practices further stabilize these standards. Road building equipment, such as paving machines and striping tools, is calibrated to operate efficiently within standard dimensions. A paving machine designed for a 12-foot lane can operate continuously without adjustment across long stretches of highway. If lane widths varied frequently, the construction process would become more complex, slower, and more prone to error. Similarly, maintenance operations depend on consistency. When roads are resurfaced or repainted, crews rely on standard measurements to restore lane markings. The expectation of uniform width allows maintenance to be performed quickly and predictably without the need to reassess dimensions at every segment. Vehicle design also interacts with these standards. Manufacturers design vehicles with an implicit understanding of the space available on roads. While there is variation in vehicle size, most passenger cars and commercial trucks are built to operate comfortably within standard lane widths. This alignment between infrastructure and vehicle design reinforces the stability of the system. Driver behavior, in turn, adapts to this consistency. Over time, drivers internalize the spatial expectations of a lane. They develop a sense of how much room they have on either side, how closely they can pass another vehicle, and how to position themselves within a lane without conscious calculation. This learned behavior depends on repetition. If lane widths varied widely, this internal model would be less reliable, and driving would require more constant attention to lateral positioning. The standardization of lane width also supports interoperability across regions. A driver moving from one state or country to another encounters roads that feel familiar, even if signage, language, or traffic laws differ. This continuity reduces cognitive load and allows drivers to focus on other aspects of navigation. Importantly, the standard is not applied uniformly in all contexts. In urban areas with space constraints, lane widths may be reduced to accommodate sidewalks, bicycle lanes, or parking. In such cases, the deviation from standard width is a deliberate design choice, often accompanied by lower speed limits and additional visual cues to signal the change. The existence of a standard makes these deviations meaningful. They are recognized as exceptions rather than norms. Over time, the repeated application of lane width standards has created a self-reinforcing system. Engineers design roads according to established guidelines. Contractors build them using equipment optimized for those dimensions. Drivers learn to operate within those spaces. Vehicle manufacturers design products that fit comfortably within them. Each component of the system supports the others. This stability does not mean that the standard is immutable. Ongoing research continues to examine how lane width affects safety, traffic flow, and land use. In some contexts, narrower lanes are being reconsidered as a way to reduce vehicle speeds and improve safety in urban environments. In others, wider lanes may be used to accommodate heavy vehicles or higher speeds. However, any change to the standard is approached cautiously. Because the system is so interconnected, altering one element has implications for many others. A change in lane width affects not only road design, but also construction practices, maintenance procedures, driver expectations, and vehicle compatibility. This interdependence contributes to the persistence of existing standards. What emerges is not simply a technical specification, but an institutional equilibrium. The consistent width of highway lanes is the result of coordinated decisions made across multiple domains, each reinforcing the others through repeated use and shared assumptions. On a highway, this equilibrium is not immediately visible. Drivers do not measure lane widths as they travel. They do not consult design manuals or consider the calibration of paving machines. Yet their ability to maintain speed, change lanes, and navigate complex interchanges depends on the reliability of the space around them. The lane as a unit of roadway functions because its dimensions are stable. That stability is maintained not by any single authority, but by a network of standards, practices, and expectations that have been aligned over time. As traffic systems continue to evolve with the introduction of advanced driver assistance systems and the gradual development of automated vehicles, the importance of consistent lane geometry may become even more pronounced. These technologies rely on predictable environments to function effectively. Variability introduces uncertainty, while standardization provides a foundation for reliable operation. Even as new technologies are integrated into transportation systems, the underlying structure of the roadway remains largely unchanged. The width of a lane continues to define the space within which vehicles operate, guiding both human and machine behavior. In this way, the consistent width of highway lanes is not merely a design choice from the past. It is an active component of a system that continues to function in the present, supporting the movement of millions of vehicles each day through a shared and stable spatial framework.